we talk about order list with linked list. So let's look at the image first. So I'm going to draw, let me just draw the box first. So we have nodes. These are nodes, right? And we have the line to split between the element itself and the pointer to the next node. Now, if I have an element, let's say this is going to be let's say E in here. So we have E, F, H. Alright, so this is at the end. Now, we're pointing like this. I want to insert a new node, right? And this node is let's say it's going to be G, right? So I'm going to insert G, which is when we insert, we say we're going to create a new node, right? So let's check our code now. Alright, so I'm going to have this drawing next to each other, then we see how it works. So we said we create a new node. So we want to write a logic for this, right? So we have the new node. That's a new node. And now we know that first we have to check if this is going to go in the beginning, right? Insert in the beginning or in between, which we know G is going to be in between. How do we know that it's in between? We said, okay, first if the list is not empty, right? If the list is not empty, we said new node dot set pointer to LL pointer. Now where's LL pointer? LL pointer actually now is right here, right? LL pointer is right. This is where LL pointer is. Okay. So LL pointer is pointing there. So we said set pointer to LL pointer. If I set this new node pointer to LL pointer, is actually insert in the beginning, right? Which is this is for it should not work here, right? So this one is not correct right here. This is from the previous code I think that we used. So for stack, right? We always insert the beginning. But this is an order list, it will not work. So it will work right here, right? In the case that we want to insert in the beginning, like for example, if I'm not inserting G. So if I want to insert D, right? So if this new node is D, not G, right? Okay, so if I'm inserting D, so we know D should go set that to LL pointer, right? Which is at the beginning right here, we set new node pointer to LL pointer, right? So this is LL pointer. Now it's not done yet, right? Because after that you have to move LL pointer to new node, right? So the code's going to look like this. LL pointer now equals to new node, which it looks like I have it down here, right? Which this time I'm going to move in first because we don't know if we need to always move, which we should not always move if it's just in between. So that's why it should be in the if statement, not outside. And then we do count plus plus, right? So this is, I just insert D, right? It's in case of D here, not G. It should be right there. And how do you know that it should be right there? We didn't check yet, right? We know check insert the beginning. How do we check? We said when LL pointer equals the current, right? And where's our current? We didn't initialize our current yet. So we have to initialize our current location, right? Current should be equals to where? Equals to the LL pointer. Right, so we should have another, let me pick a different color. And this is like our next pointer where we say this is current, right? Okay, so that's a current pointer. So when we say they are equals, if they're equals, and how do you know that's equals? We have to actually iterate the loop first before we can insert D, right? We have to compare the new contents to the old contents, correct? So how do we compare? We have to iterate through this to find the location, right? So meaning that we have to do a loop here, right? While, right? Since we already have this initialized that, hey, this is like when you do loop, you say in count equal to 0. This is like current equals to the beginning point, which is LL pointer. And while we want to find location to insert, which is the object, we compare the contents, right? While like the new elements, which is D, is less than the current existing element on the list. That's when you want to exit the loop, right? So while current is greater than, you keep looping, right? So that means current dot get element, right? Dot, and we know the element itself, like we did create a count with comparable. So we should have the method compare to, right? Let's check. We don't have that yet because this is E type. Right, so if we look at our users, let me open users that we create last time. All right, so current.get elements. In this case, it's going to get the username, and let's say username happen to be a letter D, right? Right, so, or if it's current, it's actually going to be a letter E right here. And this is comparable, so we have the method name compare to, which is an object. Right, and just get username, compare them, right? And return 0. If it's equals, less than, negative, greater than, positive. But this one is doesn't know I'm going to be a user or not, right? we want to make sure that the E here have to be implemented by comparables. All the classes or the object has to be implemented by comparable in order to use linked list here. Otherwise, it will not work because we have to call .compare to. So how do we make sure it happens? We have to make sure it extends comparable here. Comparable T type. So the iList extends E extends may not need this. Iterators E extends comparable. So if we review the concept of the generics, right? So let's review the concept of the using the generics here, like with the comparable interface. So when you have comparable interface, right? So you have the generic E. So you have the compare to methods, right? That you can compare any elements. And like for example, integer class has extends like number form, inherit from number class, also implements comparable integers. So pretty much just has to implement the compare to, right, integers. Now, when we start to, let's say, sort, right, this is very relevant. Like an order list, we need it to be sorted, right? But this is an array, right? Arrays.sort is going to sort this, right? But in order to make sure that it can sort, arrays is a class. The object that's going to be sortable has to be extends comparable, which is have to implement compare to. Otherwise, the sort will not work, right? Since all comparable objects has to have the compare to, that's why arrays.sort is now worked, right? We have arrays.sort. We've seen that it's in CSC200, right? Yeah, and string pretty much has that comparable capability. We know that string has the method compare to, and big integers also have, so that's why we can sort. Think about if you have your account like user and you try to sort the user, it will never work if you don't have compare to. Okay, let's test that. First, we gonna look at array is pretty much just from Java API, right? So we're gonna look at array Java doc here, the code that we just looked at just now. Arrays, right? And we want to look at how the generics for .sort, right? When I do .sort, this is overriding sort object.